Okay, number 2 technique, sometimes just simplifying, first of all, algebraically is what you need to do. For example, if I have the limit as h approaches 0, and that's going to be a 4 plus h squared minus 16 divided by h. Well, let's approach this one. Let's just simplify the numerator. Here's what I mean by that. Let's go ahead and square out the 4 plus h. 4 plus h, 4 plus h. Multiply that thing out there, okay? What would that be? 16, that'd be 4h, another 4h, pull it out, h squared. And so that'll be, this 4 plus h squared will be 16, it'll be plus 8h plus h squared. And then don't forget the minus 16 and the divide by h. Simplifying that out does help me, right? Because what happens when I do that? Don't the 16s here, you got a 16, you got a minus 16, those are gone. So you have the limit as h approaches 0 of 8h plus h squared divided by h. Now, I did check it a while ago, but the bottom is definitely 0 on this, right? Starting out. And it's still 0. However, now we can go revert back to technique number 1 there, because what can I do here? Pull out an h. One way you can look at it anyway. Pull out an h on top. Be 8 plus h in parentheses divided by h, but now the h's cancel. So now I have just the limit as h approaches 0 of 8 plus h. Substitution now is okay, right? H goes to 0, so now just, since the h is in the bottom's gone, now I can just substitute limit's 8. All right? All right. Let me do this one right here with you. Limit as x approaches a, x squared minus 3x plus 2 minus, parentheses, a squared minus 3a plus 2 divided by x minus a. I don't know how many they'll have in this homework, but in the very near future, this will happen. Notice here, I'm not going to a number here. X is going to a. It's kind of like we're doing it in general. However, notice, we have the same difficulty in evaluating this limit, don't we? Because if I plug in x to be a, what does the bottom become? 0, okay? So I run into the problem, denominator 0, so I run into the same difficulty here. So what do? Well, I mentioned it under technique 2 here because, yeah, let's simplify what we can on the top. And of course, that's, first of all, is just, don't forget to distribute your minus there. Minus times a squared is minus a squared. Minus times minus 3a is plus 3a. And then minus times 2 is minus 2. And really all that simplifies then is the 2's. So wind up with this. Limit as x approaches a, x squared minus 3x minus a squared plus 3a for x minus a. Okay? Well, now, just like the other, I need to see if I can go back to factoring here. And I mentioned this one because this is a different factoring maybe you hadn't seen in a while. But I can factor. Do you see how I can factor the top? Grouping. The little grouping factoring. If I group these two and then group these two, here's what I get. That'll be x times x minus 3, right? Because look at the first two, there's a common factor of x. Pull out an x, so it'll be x, and then parentheses x minus 3. Now in the second one, I'm going to pull out a minus a, and notice that'll be it'll be a minus 3, won't it? Which is not what I needed. Okay, let's see. Maybe I need to, no? Oh, I see. Okay, here's what I have to do. Let's regroup here. Regroup a little bit. Let's make it, is this really the easiest way? A squared, x squared minus a squared, and then minus 3x plus 3a. Just regroup it there. Is that the easiest way? Huh? Yes. Oh, a com. Well, we weren't quite there where we could cancel it yet. Okay. But I think this way, if you group these two, that's a difference of squares. So that's x minus a, x plus a. This really wasn't what I had in mind. But anyway, all right. This will be, and then you have these two have a common factor of minus 3. And so that would be x minus a there. Okay. All right. So now, now we have that common factor that I can cancel out, can't I? See that? I've got a common factor of x minus a. I can cancel all the way out there. All right. So this is the limit as x approaches a. And what I have left is x plus a minus 3. Because the x minus a's have canceled. I don't know that you'll have one like that, but just showing you something like that can happen. All right. Now, here's the other thing. If I substitute, x is going to a, so I'm just substituting for the x. This is really one of the main things I wanted to mention. If I substitute, the a goes in for the x, and so don't I have a plus a minus 3, or 2a minus 3? Combining like terms. Yeah, one of the main points I wanted to do on this one, maybe not this one as complicated, but a thing. But yeah, sometimes the answer, and this will happen more later on, but sometimes the answers won't necessarily just come out to be a number. They'll come out to be an expression themselves. Okay? But anyway, any questions on what I did there? Like I said, I don't know that there'll be anything quite that complicated you'll have to do. But all right. Okay. Let's see here. Let's talk about limits with square roots a little bit. Has everybody got this one? Okay. All right, a little bit on limits with square roots. When we come across a limit with a square root, let's see how we can go about that. Limit as t approaches 0. And the top's going to be the square root of t squared plus 9. And then minus 3 on the outside. And then the bottom will be t squared. And so this definitely fits under the category of a limit with a square root. But we notice same problem as before. Can I substitute directly? I cannot, because the bottom would be 0. Common theme there. The technique on solving these limits with square roots when you can't directly substitute is multiplying by the conjugate. Now, do you know what I mean by conjugate? What do we mean by conjugate? Any thoughts? Well, the conjugate is, usually on a conjugate, you change one little thing, you change a sign between two other things. And that's what we're going to do here. I'm going to take this limit, and I'm going to multiply by the conjugate of the top. And so the conjugate of the top, all I do is I change it, the minus to a plus. So very same square root, t squared plus 9, 3. The only change is it's a plus 3 instead of a minus 3. That's called the conjugate of the top. Well, to make this a legal maneuver, what do I have to do? Same thing in the bottom. So multiply the bottom by t squared plus 9 plus 3. Same thing on the bottom. Okay? All right, so simplifying this out. Well, let's cut to the chase here a little bit. Won't write it all out, but what do I get? Of course, it's got to be FOILed, but what do I get if I FOIL this? This times this, well, I've got the t squared plus 9 square root times the t squared plus 9 square root. What does that give me? T squared plus 9, no square root, right? The square roots kind of cancel one another out, so to speak, or combine to make 1, or I don't know how different ways you can look at it, but yeah, square root of t squared plus 9 times the square root of t squared plus 9 is just going to give you square root. It's just going to give you t squared plus 9. With me on that? Okay with that? All right, and I'm not even going to write the next two, because what happened? If I take the square root of t squared plus 9 times 3, and then I take the minus 3 times the t squared plus 9, what happens? Those are going to cancel out, aren't they? Because I have a positive 3 times the square root of t squared plus 9, and I'm going to have a minus 3 times the t squared plus 9. So those cancel out. No need to write those. And so then last but not least, I have minus 3 times positive 3. That's a minus 9. So the top all is this. Then on the bottom, I have t squared times the square root of t squared plus 9 plus 3. And I'm not even going to multiply that out. The top is really what I need to multiply out. You can multiply, you can distribute the t squared if you want, but I wouldn't at this point. You'll see why here in a second. All right? You'll just have to factor it right back out. Okay, well, what happens here is, notice, you got plus 9, you got minus 9. So the top is just t squared. Hey, that's nice, because what happens then with that t squared? It cancels nicely with that t squared on the bottom. And that leaves me just the limit, t approaches 0, of 1 over the square root of t squared plus 9 plus 3. So notice my problem has gone away. The problem was when I plugged in 0, I got 0 on the bottom. I don't have that anymore, do I? Now if I substitute t to go to 0, if I substitute t as 0, I don't have 0 in the denominator, do I? So I can substitute.
Substitute that in. That gives you, well, that's just square root of 9. That's 3. So you have 3 plus 3, don't you? 1/6. 1/6. Question or concern? Is that okay? All good? All right. Well, let's see. What about this one? The limit, x goes to 0, x over square root of 3 plus x minus square root of 3. Can we substitute? No. Okay. Cannot substitute. But it is one of these limits with square roots, and so we know multiplying by a conjugate might be a good thing here. What conjugate am I going to use here? Well, in this case, it's the denominator that has the square roots in it, so that's where I apply the conjugate, is to the denominator. You don't always have to do the conjugate to the numerator. Sometimes you'll do the conjugate to the denominator. So that's the case here. X over square root of 3 plus x minus square root of 3. So we'll multiply the conjugate of the denominator. What's the conjugate of the denominator? Square root of 3x, square root of 3 plus x plus square root of 3. Just change the denominator over there, sign-wise. But you have to multiply the numerator too by the very same thing. Okay? What happens? Hopefully nice things happen. I think they do. Limit as x approaches 0. On the top, I would just leave that, not multiply that out. Just leave it x times the square root of 3 plus x plus square root of 3. Because we're going to wind up canceling that x anyway. Then the bottom, well, you know the story there. You got the square root of 3 plus x times the square root of 3 plus x. That's 3 plus x. Square root goes away. Then in the middle, we'll have the square root of 3 plus x times the square root of 3, but then we'll have minus that very same thing, minus 3. So those go out. Don't need to write that. Then I'll have, last but not least, square root of 3 times minus square root of 3. What is that going to give you? Minus square root of 9, which is minus 3. You with me on that? Bottom is 3 plus x minus 3. But hey, look at that. 3's go out. So the bottom is just x. But that's even better, because then what can I do? Well, then I can cancel the x with the x on the top, and I wind up with just limit x approaches 0. Square root of 3 plus x plus square root of 3. Now I can substitute, can't I? Which brings up my next point. What do I get there? Well, if I substitute x as 0, I wind up with the square root of 3 plus the square root of 3, which if I'm going to simplify that, how much is that? It's 2 square roots of 3, isn't it? You got a 1 square root of 3, you got another 1 square root of 3, so you got 2 square roots of 3 there. How about that? Question or concern about any part of that? Is that okay? All right. Well, we did square roots. Let's talk about limits with complex fractions, fractions on top of fractions. All right. Say I've got the limit as h approaches 0, 1 over 5 plus h minus 1 over 5, which is a fraction, 2 fractions, but then I'm going to complicate it, make it a complex fraction, and put
all of that over h. Complex fraction. What do we do there? Well, one way of doing this, there are others, but one way of doing this is, combine fractions. Combine the top fractions here. If I combine my top there, I need a common denominator. Just leave the over h, which is the problem here. It's over h. H is going to 0, so it's over h. Yeah, that's a problem. Okay, but yeah, how would I combine these fractions? Well, they're subtracted, so what do I need to subtract them? Common denominator. And so, wouldn't the common denominator be 5 plus h times 5? The LCD is going to be 5 plus h times 5. Okay, well, to make the first fraction be 5 plus h times 5, don't need to multiply by 5 over 5. I do believe so. And then the minus 1/5, what do I need to multiply it by? How about 5 plus h? So this is one way to do it. Combine those fractions. All right, so that'll give me limit as h approaches 0. Bottom over h still there. It's all good. But now I have, don't I, the bottom the same, so I can actually subtract these fractions, combine them, and get one common denominator there. Now what's the numerator? Well, the numerator here will be 5, and the numerator here, be careful there, the numerator here will be, won't it be minus 5 minus h? Because that's a minus 1 there. Is everybody okay on that? Just combining the fractions there. Okay, well, we can obviously see the 5 and the minus 5 are going to go out. Wind up with this. Now, perhaps you can see what to do next, but here's a little explanation. This here, of course the top is minus h, 5 plus h times 5. And this over h is synonymous with, isn't it, divide by h? Isn't that what over h would mean? Divide by h. Okay, well, I put it in that form because doesn't divide by h mean times 1 over h? Isn't that how you divide h, is multiplied by 1 over h? And why would I want to do it that way? Well, since I have now this format, can I cancel these h's out? I've got an h in the denominator and h in the numerator. So yeah, I get the limit as h approaches 0 of minus 1 then would be on top, 5 plus h times 5 on the bottom. Now what? Now I can do my substitute, right? I don't have a problem now 0 being the denominator, so I can substitute. Substitute the 0 for h in. What do I get? Minus 1 over 5 times 5, 25. Is that okay?